Question 3 and 4, I need to evaluate trigonometric values for number 3. So the first thing that you need to do is to identify the sides A, B, and C. That is, I need to identify the hypotenuse, the adjacent to the angle theta, and the opposite. And here, I just need to know SOHCAHTOA. So the sine of theta would be opposite, which is B, over hypotenuse, which is C. And in that case, I will have 12 over 13. And you do not need to be that detailed. Cosine of theta would be A, the adjacent over the hypotenuse, that is 5 over 13. The tangent of theta would be sine over cosine, so the over 13 will cancel out, and I will have 12 over 5. And to get the reciprocal values, that is cosecant of theta, secant of theta, and finally cotangent of theta, I would just flip the top and the bottom. So I'll have 13 over 12, 13 over 5, and finally 5 over 12 for the cotangent. For number 4, I need to solve the triangle. So the only data I have here is C and alpha. That means that I need to figure out how to get A, B, and the angle beta. So here, which won't be the case in during the test, but we're going to take advantage of that here, is I have to use the calculator. And because I am given an angle in degrees, I'm going to make sure that my mode, when it comes to angles, is set in degrees. Here we go. All right. So the easiest one to get is probably the angle beta. So beta will be the complementary angle of alpha. So it's going to be 90 minus alpha. So 90 minus 36.8699 would be 53.1301 degrees. And from there, you have many possible routes. Let's start with B. Let's find B using alpha. So with regard to alpha, B is the adjacent, and I've got the hypotenuse. And the trigonometric ratio involving adjacent and hypotenuse is cosine. So I will have cosine of alpha will be equal to B that I'm looking for, divided by the hypotenuse C, which is 10. Which means that B will be equal to 10 times cosine of alpha. And that would be 10 times cosine of alpha, which is 36.8699, and I have 8. Now here, you could very well find A using the same angle alpha or beta, since you have it, or using the Pythagorean theorem. Let's do both, and you will choose to do the way you prefer for whatever exercise I'm throwing at you. So, using the Pythagorean theorem, A will be the square root of c squared minus b squared. In that case, is going to be 10 squared, which is 100, minus 8 squared, which is 64, and I will have the square root of 36, which is 6. So this is using the Pythagorean theorem. The fact that a squared plus b squared equals c squared. But I can very well keep using the trigonometric ratios. In that case, I'm going to use sine of alpha. Sine of alpha, since a is the opposite with regard to alpha, sine of alpha will be a divided by the hypotenuse c, which is still 10, which means that a will be equal to 10 times the sine of alpha. And 10 times the sine of alpha, which is 36.8699, would be 6. See, those results are consistent. You do not need to do both if you are not being asked to. And that's it.